Raising the corporate average fuel economy standards for vehicles to a goal of 54.5 miles per gallon by the year 2025 is enabling the increased use of steel because advanced high-strength steel is the automotive material that best addresses society's need for fuel-efficient performance without compromising safety or affordability. In that regard, steel truly offers the complete package. To understand why, let me first explain a little about steel. Automotive advanced high-strength steels are principally alloys of iron and carbon and obtain their wide range of properties and very high strengths largely from controlled heating and cooling during processing in our steel plants. Steel is made in a series of highly automated processes which allow for its properties to be precisely engineered to meet customer requirements. This allows for the continuous reinvention of our material. Think iPhone. For example, the iPhone 1 came out some 5 years ago and has been replaced by iPhones 2 through 4, and now iPhone 5. And look at the dramatic improvements in performance. In roughly the same amount of time, the steel industry has developed a new generation of advanced high-strength steels, and the improvements in performance over the steels they replace are just as dramatic. Just to be clear, this is the beginning of these innovative new steels. Have you heard about the new aluminums? Me neither. The first reason that new vehicle regulations will enable increased use of advanced high-strength steels is because of the unique properties of steel, set by the laws of chemistry and physics, allow for continued advances in performance, for example in strength and formability. These properties are important in taking weight out of vehicles while maintaining safety performance. Higher strength means less material is needed, and higher formability gives the auto designer latitude to use sophisticated shapes which also reduce weight. The future steel vehicle designs announced by our industry within the last year resulted in a 35% weight reduction and a projected 5-star safety rating, which is the highest possible rating, all at no increase in cost to the car maker. The second reason new vehicle regulations enable growth in steel use is cost. Changing from traditional steel to the many varieties of advanced high-strength steel provides the lowest cost per pound removed from the vehicle compared to alternative materials like aluminum and carbon fiber. Car makers are challenged to increase fuel consumption affordably, and this is best done with steel. As an example, even with gas at $4 a gallon, hybrids and other alternative fuel vehicles remain only at about 2% of the market due to their high cost. Last year, for example, the steel industry designed a front-lower control arm, a part of the steering system using advanced high-strength steel. The result was the same weight as the aluminum control arm that was being used, but at 30% less cost. The manufacturer shifted to steel. Next year, we are launching new lightweight chassis programs and a steel-intensive engine program designed to replace other materials with light and affordable steel alternatives. Again, cost and performance ultimately determine materials choices. In addition to steel's lightweighting capability and cost advantage, an equally important attribute is its superior environmental performance. Steel production emits about 1/5 the greenhouse gases of alternative materials like aluminum. Already, Mercedes and Volkswagen use life cycle models to calculate the emissions associated with materials choices so they can factor environmental impact into the design of vehicles. Domestic vehicle manufacturers are also well down this path. The aluminum industry claims its emissions are less when it uses recycled aluminum, but there is no significant aluminum sheet available for recycling since most of the aluminum used today is in engine and other cast parts, not sheet products. Of course, there are some hoods and fenders from old Jaguars and Audis available for recycling, but on average, there are only about 30 pounds of aluminum sheet in vehicles today. Simple math says to achieve aluminum's goal of adding over 200 pounds of aluminum sheet per vehicle, the increase will have to be made using emissions-intensive primary aluminum production. This is as significant a concern as is their high cost. New vehicle emissions regulations, then, provide a great opportunity for steel to create low environmental impact solutions for car companies while maintaining cost and performance advantages in contrast to competing materials. Using steel in automotive manufacturing allows car companies to put their customers in safe vehicles they can afford to buy. They can also afford to operate them because of the lightweighting possible with steel, which lowers fuel consumption. What are some other benefits of steel? Again, it comes down to the cost to the ultimate consumer. What happens if you're in an accident? How easily and affordably can you repair a car with aluminum parts? Can you bang a dent out of a fender and avoid a complete replacement of damaged panels? And with aluminum between 2 and 3 times more costly than steel, how much more will that replacement part cost? And what happens to your insurance bill with alternative materials? Clearly, the advantages of steel go beyond both the performance of the vehicle and the life cycle emissions, as we have discussed. Steel's advantages also reduce the lifetime cost to own and operate the vehicle. Advanced high-strength steels are sophisticated new materials which are precisely engineered to meet specific needs. Due to advances in modeling and materials science, steelmakers can manipulate the molecular structure of these materials on the steel plant floor. Let me explain. As I mentioned earlier, steel is an alloy of iron and carbon. We can alter the properties of steel by altering the chemistry, meaning adding other elements, and/or by heating and cooling in our various processes in the plant. The physical properties of these elements are very important, and so is the use of oxygen in steelmaking. Many of the elements used in steelmaking would rather bond with oxygen than iron. This is important because steelmakers then use oxygen to remove unwanted elements or impurities from steel. This allows for the most extensive recycling on the planet and is why one steel can be recycled into another. In other words, the steel from cars becomes the steel in bridges, which becomes buildings, which becomes appliances, and the cycle continues. This is why steel is the most recycled material in the world. 88% of all steel products are recycled here in the USA. By way of contrast, aluminum's physical properties are such that other elements and/or impurities become trapped in the aluminum alloy. This presents problems during recycling. That is why one type of aluminum is generally recycled to that one type. For example, used aluminum beverage cans become new beverage cans, not a panel in an automobile. Different aluminum grades must be sorted and separated, adding to the cost of that material. Advanced high-strength steels, therefore, are new materials that offer automakers the complete package: unparalleled crash performance for safety, reduced vehicle weight for fuel efficiency, and affordability to consumers.